Hi guys, today we are solving 1359. Count all valid pickup and delivery options. I'm going to jump to the solution right away. So it's a very basic permutation and combinations problem where we are given n pickups and n deliveries. So in total we have 2n items, right? Let's see. Suppose in permutation and combination, we are given four items A, B, C, and D. And we are given into one condition like all the A needs to be coming before all the B's. The occurrences of the element A should come before B. This is the constraint given us. Suppose this example, and we are given four different items. And you are asked what are the total number of possible combinations available, both including all the combinations and all the permutations as well, which are following this basically given criteria. So we know that let's forget this criteria for now. Let's forget this even exists. If we go by solution is this of how many permutations exist of permuting these four candidates, we know it's going to be n factorial, so which is 4 factorial, because we have four different elements, one, two, three, four, and we can fill up by anything. And we are, because we're counting permutation, is going to be n factorial, right? And we also know if we are giving just one constraint that all the a needs to come before b, if we are giving this one constraint, we need to divide it by 2. This is what we studied in permutation combination class 11th. If you have not studied by chance, this is the first time you're encountering it, then just this is one of the concepts which has to be in your fingertips in permutation and combination, is that if there are n objects, or like there are four objects and you need to count all the possible permutations, then you divide it by, then you consider it by 4 factorial, or the n factorial. So n factorial is the number of permutations, and the number of constraints you have. Like suppose we have just one constraint like this, so it's divided by 2. Suppose I have one more constraint along with this, and it's saying that a should also be greater than let's say d. Because now I have two constraint on a, the answer should be n factorial, which is the total number of permutations without any constraints, divided by 2 into 2. Why? Because we have two restrictions now. Suppose there is one more restriction of a greater than c. If we have three such conditions, then the answer should be n factorial divided by 2 into 2 into 2. Right? This is the thing that we studied in class 11. Right? So in the coming back to the original question, we have n pickups and n deliveries. So in total, we have 2n objects, right? 2n objects. Because we have 2n objects, the number of possible permutations, let's say 1, 2, 3, 4, 5. This is the list of how many 2n objects. If I just permutate all the possible permutations of arranging these pickup and deliveries, is how many? It's going to be 2n factorial, right? And because we have how many restrictions, can you see? All the pickup has to be possibly, all the possible pickups have to be always occur before the delivery. So any pickup of I needs to be coming before the delivery of I. So we are having this constraint. If we just go along and follow this constraint, how many restrictions do we have? We have n restrictions, because there are n items, there are n orders, right? Because there are n orders, so we have n items, so we are having n restrictions, correct? So the answer should be 2n factorial divided by 2 into 2 into 2. How many times? N times, because we have n restrictions. Or in other words, if I write it, it should be 2 raised to power n. This is your answer. So if you can do it, it is the answer. But if you just program this thing, which I definitely did, as you can see here, it's giving me wrong answer for few of the cases. Why? Because finding 2 raised to power 500, as you can see, the n constraints are pretty large. So this is a very, very large number. This is very, very large number. Also, counting this one is going to be very tedious, because as you can see in the question we are giving, all the computation needs to be done in integers, and since it's integers and you also need to be taking this mod every time it overflows, I have to mod every time, right? So I cannot blindly for do and go and do a 2n factorial divided by 2n. Though this is the correct logic, this is the correct answer, we have to dive down deep into binomial theorem in class 11th, which we studied. So as we all know, just reset everything and just listen from here. What I'm telling you is, suppose we have something like this: uh, 2n factorial. If we have something like this, it's written as, so this is written as 2n into 2n minus 1 into 2n minus 2 all the way till n plus 1 into n into n minus 1 all the way till 2 into 1. So this is what 2n factorial looks like, right? If I just keep all the even numbers, if I just group all the even numbers together and all the odd numbers together, it's going to look like 2n minus 1 into 2n minus 3 into minus 5 all the way till n plus 1 all the way. Okay, just ignore this one. It's going to all the way till 1, like 3 into 1 and stuff. I'm going to just group it, and all the odd ones, right? All the odd ones, all the evens should also be grouped to 2n minus 2 into 2n minus 4 all the way till 4 into. So I'm just grouping these two items together. So the above series can also be written like this. I'm just dividing all the evens and the odds together. And now from this one, let's remove the 2n from here, right? So I'm removing 2n from here. So it's going to become 1 into. Okay, so this can be further simplified into. Uh, okay, let's simplify this one. I'm picking all the twos out. So picking out a two from here, then from here, then from here. From all of these terms, I'm removing one, one, two. So here, 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 it's going to, how many twos can be coming out? 2 to the power n. This is the accumulation of all the twos coming out of this ladder. So what will be inside? It's going to be 1. It's going to be n into n minus 1 into, this will become what? This will become what? N minus 2, right? This will become what? Bringing out a 2 from here. So it's going to be what? N minus 1, right? Which I've written like here. And similarly, this will go and this will become what? 2 into 1. And okay, this is written like this only. Same. Let's simplify it. In the next step, we have what? This can be written as, okay, I'm just reversing it. 1, 2, 3 into dot dot dot. I'm just reversing it. 2n minus 5 into 2n minus 3 into 2n minus 1. Correct? Just keep it here. Is going to be multiplied by 2 raised to power n multiplied by, this can be written as n factorial, right? This can be written as n factorial, and this is what? 2n factorial. I'm just simplifying this correct mathematical expression. I'm sure many of you have done this in your class 11th and 12th when we studied this topic initially. So this can be further be written as, if I just totally simplify it and give you the final answer and the result that I hope that you hopefully remember, because it's a pretty general thing. 1 into 3 into dot 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 2 to the power n minus 1 into n factorial. Correct. So this is something that you should remember, and this is a pretty standard result. This is something that you should always remember. I hope you get the point. Yeah, remember this one. Okay, so it can be written something like this. What is this? This is I. This is what? Second term is written as what? 2i minus 1, like this only, because this is also 2i minus 1. Because if I put I equals to 2, then this is equals to 4 minus 1. Simply, it's something like 2i minus 1 into I. Summation I equals to 1 to n. 2n factorial divided by 2 raised to power n. I hope you do remember this thing, right? This is a pretty standard answer that you should remember always. Like, this is something that you should remember. 2n factorial divided by 2n is equals to 2i minus 1. Like here, it's 2i minus 1 multiplied by I and summation of this to, or you can remember it by this way. This is a better general answer to be remembered by. This is still the mathematical form of the same thing, so remember this. So I'm writing L by H, or which is learn by heart this result. Similarly, so what we need in this Anna question, we needed this. So this was the answer for us. So instead of writing this in this form, let's program it and write the answer as this. I hope the proof is clear to you. So let's first write the answer, set it to and return that answer. And let's do a for loop from I goes to 1, I less than equals to n, and we have to do what? Answer equals to, every time I have to do what? 2i minus 1 into I. So let's do it of what? 2 into I minus 1 into I, right? This is the answer, and because you have to multiply all of these are in the multiplication or as a product. So I have to store this in my answer, correct? And this is, I guess, more than sufficient to, let's run all the test cases. Okay, so I guess it has to be passing. Let's run all the test cases. Come on. Okay, one more thing. This mod thing we're forgetting. So before we submit, let's do this mod thing also. 197 plus 190 plus 7. And just put a mod here. Let's submit it now. I guess it has to work. No. We are getting a sign integer overflow, which is saying that it cannot be represented in an answer. Let's put it long instead of answer. So answer, because as you can see, it's being multiplied again and again. Okay, now it's getting submitted. So I hope you understood the solution. And if you have any problems or anything that you need to ask, do ask me down in the comments below. And thank you. Have a nice day.